Good morning again. My name is Cyrus Liu. I work for Austria Control, and we have a partnership agreement with EASA. And under this partnership agreement, I'm acting as avionics expert, as electrical expert, and as PCM on several types of aircraft, except rotorcraft. At the very beginning, it is unleashed. I'm not a human factors expert. So what is the aim of my presentation for today? The main aim is to generate awareness, because what I know is how operation deals with what we are designing, with what we are approving. So the first step is I just want to have a general background information, so why to consider human factors. And then the areas I think is important to consider and what we experienced in real life. So I want to focus on some examples we collected in the past, and hopefully we will find a conclusion on this presentation at the end. So let's start with the general background. We all know that the human being might be the weak element in a system. We all agree on that safety is paramount in aviation. And we all know that different kind of specifications or rules already adapted for human factors, like CS25, like Part 145, like the OPS rules. But I would have at the very beginning a question to you. How many of you received recently, so let's say in the last 12 to 24 months, a human factors training? Hands up. I didn't. Hey, cool. So we'll be fast on the first slide. Thank you. How many of you received a human factors training which was tailored to the design of aircraft? Hands up. Okay. Thank you. And how many of you know somebody who had such a training? Okay, so from what I see so far is that not everyone in the room is really trained in human factors, correct? When we hear about human factors, the first thing which comes into mind is, as an avionics guy, is the primary field of view, normal field of view, and all these field of views we have. Then we have the colors and all this stuff. But there is much more about, except what a human being can see. Those having the training on human factors, if I say something wrong, correct me through the Slido, please. Thank you. We have to address in our design the physical, the cognitive, and organizational ergonomics. And there are some projects ongoing to better understand what is ongoing in a human brain or in a pilot's brain. The physical ergonomics concern mainly the human anatomy. You can read through this as well, but every one of you knows that if you're not comfortable, or if you have undue fatigue, if you have to concentrate too much, you will get tired, and it might also result in pain. I talked to a helicopter pilot some time ago, and he was involved in a night vision goggle operation approval. And he told me after the first session, flying half an hour with the stuff, he was completely exhausted. He didn't know why. It was like night VFR, except that he is able to see much more than without the goggles. After further research, we found out that he had to move his head much more, the scanning was much more, and he had to concentrate much more because his field of view was reduced. So things which are not obvious at the very beginning come up when you use it. If you compare a car driver with a truck driver, you will figure out that the truck driver has much more mirrors. So he gets tired much easier than a car driver. These are more or less standard and obvious thing, but we have to think about it when it comes to our design, or sorry, to your design. The cognitive ergonomics is the mental process affecting humans and the human-machine interface. I just want to point out memory. If you have a system which relies on memory of the pilot, that he knows exactly to push 20 times this button and then turn this knob, and without any logical background here, he will have to concentrate much more. And this affects his decision-making process. So this might result in undue fatigue again and further work stress. Organizational ergonomics, we normally say, oh, it's regarding the operator, so we do not have to take care about. But I just want to point out on this slide here, or on this graph here, it shows the workload on a typical aircraft and the level of capability of the flight crew during the flight. Obvious to say that at the end of the flight, it's reasonable that the pilot or the flight crew might be more tired as at the beginning, hopefully. Otherwise, they would have sleep all the time. But the workload increases at the end. So the safety margin at the end is much less. Is it a good idea to put much more tasks, much more effort for the flight crew at the end in the approach, or is it better to reduce all these tasks, all these workloads? I think you have seen this before, the Swiss cheese model. If not, it's not brand new. We know that when a problem starts, there are several, let's say, lines of defense. And there are latent failures within this line of defense, and they have to match. So one problem becomes one issue becomes a real problem. I will come to this a little bit later, but with all these Swiss cheese model and all this thinking, some question appear. So which of the 4 defense lines does design directly affect? Does the design have an impact on other defense lines? I will come to violations a little bit later, because we trust that the pilot will always do what is written in the book. How could we enhance the design to enable the responsible person to be more efficient, but with the overall goal to enhance safety and reduce problems arising from human factors? So, as an example, fail to correct a problem. Okay. I guess you all know the shell model, so I will elaborate about 20 minutes on this, so then you're asleep for sure. No, I just want to figure out that you are dealing with software, you are dealing with hardware, and you are dealing with the flight crew. The flight crew is operating in an environment, in a specific airspace, in a specific aircraft. And it requires communication. So you have the interfaces all over here with your design. So what are the areas to consider right now? In all our efforts to introduce improvements and enhance the system, we should never lose the focus on the main duties of the persons involved in these improvements. I want to mention here right now, because I have some pictures here, that kind and size of the aircraft doesn't really matter. You know, you might have slightly different topics, but at the end of the day, it's a human being operating this aircraft, using this aircraft. So we have changes in the cockpit, of course. We have changes to the cabin, which might have an impact on human factors as well. And we have changes to continuity airworthiness. So let's start with my first question. Changes to the cockpit. What is the main duty of the flight crew? Is it A, announce weather information at destination airport and look cool? Is it B, pushing buttons to enter the third level of a submenu of a system to get essential information he needs? Or is it C, simply fly the aircraft? Okay, correct answer, C. If you have a look at CS25, sorry for all VTOL and CS23 guys, I just took one of the CSs, but you will find similar things in the others as well. You will have numerous requirements already accounting for the human being, such as controllability or maneuverability, or the control system general, stability augmentation and automatic and power operated systems. If it comes to the 770 series, then we have the pilot compartment view. It explicitly says that all this stuff has to be arranged and made in a kind of manner so that the flight crew is able to operate the aircraft without unreasonable concentration or fatigue. You have installed systems and equipment for use by the flight crew. If it comes to 3009 system safety assessment, you will find in there that you will have to display warning information to the flight crew. It should be identified by the flight crew as warning. HERF. HERF is a thing. Some of you will, what does HERF has to do with human factors? During HERF testing, it might happen that some of the systems fail, some of the systems just at a certain frequency, they just have a short glitch and they recover from it, which is okay. But what needs to be assessed then is the recovery time sufficient that the flight crew or whoever has to deal with it has sufficient time to operate the aircraft safely again. Of course, we have arrangement and visibility. And the flight crew alerting, which was warning, caution, and advisory lights at the past. 3022 is really, really exhaustive at the moment. And if you have a ACNS issue 2, you will find additional information on the human-machine interface considerations. And finally, we have in CS, hopefully, yeah, 25 markings and pluckers. So, but I didn't get on the ops rules because ops rules also elaborate on human factors extensively. And you will find out that not all ops rules are really in direct line with the CSs. Let's come back to an assumption, more or less to an fictitious example. An aircraft is in an approach. It has an auto throttle installed. And in approach, so again, we are here. The radio altimeter comes up with a miscompare. And due to this miscompare, several systems go off, like the ACARS, enhanced ground box, the autopilot, which is coupled in approach mode, is disengaged. And you have a lot of red and amber warnings on the engine indication and crew alerting systems. You can imagine this. So the crew starts to identify where all these warnings and cautions are coming from. We're still in approach. At the same time, the auto throttle command idle because one of the radio altimeter tells him he's more or less in flare position, so go to flare. The throttle move backwards. The crew might be distracted from the throttle's movement because of all these red lights. You know, you have a Christmas tree in front of you, so I don't know if you have ever been in a really stress situation where your field of view gets a little bit smaller and you start to sort things out. Maybe not as foreseen by the handbook. And they might not see that the throttles move backward. Not at the first moment, after a while for sure. But if they are too slow to come back and put the thrust in again, it might happen that they lost a thrust already and result in a stall. Okay? And you were the one happily securing the deal to modify the existing radios and TCAS computers with new ones. You might think, oh, what might this have an impact? Yes, it might have an impact. I agree, it is catastrophizing. But is such a scenario really not possible? Okay, let's go to the next group. Changes to the cabin. Here again my question. What is the main duty of the cabin crew? Serve tea, coffee and meals while being unnaturally polite and look very pretty, or operating highly complex and complicated passenger entertainment systems, or ensure safety in cabin and assisting the flight crew in abnormal or emergency situations like firefighting, unruly passengers, or emergency landings. Who is for A? Okay. So it is C again. So you will see some coincidence between my questions. But when it comes to the cabin crew, it's always misunderstood, or I get the feeling that a lot of things are misunderstood. And I have some examples at the end, which hopefully make this statement a little bit more clear. So we have a requirement which says that the doors have to be safeguarded so that they can't be opened during flight. Why should everyone open a door during flight? You know, someone tried it already. So there is the need to have a requirement that no one can do this. And you will have some requirements to make sure that everyone knows that this door can't be opened in flight. The next thing is, I believe most of you came by plane here, correct? So, and I'm 100% sure, if you listen to her or him, it was said that in the case of emergency, all personal belongings need to be on board. You're not allowed to take anything with you. Get up, get out of the aircraft. This is your main task as a passenger, correct? And it's really, really a hard task, because you will find numerous pictures like this one, where people jumping out of the airplane with even a trolley. So, and if your design, just let's say you put in there a windscreen and some of this trolley blocks the forward emergency exit, and it's burning at the back. I'm not really sure if this windscreen is worth it. So think about such things also. Yeah, I know it's not written in the CS, but we know that it happens. We see that it happens. Just go to Google and, is this advertising? No. Just go to a search engine and type in there emergency evacuation, and you will find numerous of such pictures where the people are carrying their carry-on baggage. So account for it. fire extinguishers.
You can use Bing too if you want. I don't know if Alta Vista is still active. Sorry.
Thank you very much. So why to mention the fire extinguisher? Because it's the requirement says it should be conveniently located and readily accessible. And then you go through some designs and you experience that conveniently located and readily accessible could be interpreted in many different ways. So what does it really mean, conveniently located? The same is with the smoke hoods. So they need to be direct accessible and the location must be obvious. When you fly home, try to figure out where the smoke hoods are in the airplane. If it is directly accessible and if the location is obvious. And if the cabin crew doesn't look that bad, open the hatch and look what's put in there as well. So you also have the public address system where you have some requirements, and I will elaborate with the example on this one a little bit later. And you have the protective breathing equipment. But this one we don't normally touch except for the small aircraft. Oxygen equipment. It's a good thing if you do something with the oxygen equipment, have a look at the operating rules, because operating rules have a really clear understanding of how much oxygen you require at which height and all this stuff, and that this has to be calculated for each flight. So it is a good idea to have a look at the operating rules here as well. And finally, we all know the safety equipment and its location. And you won't believe what you will find as safety equipment in aircraft flying around for 10 to 15 years. So, the last group. Changes to continued airworthiness. Again, the question, what is the main duty of the maintenance crew? And be careful, I was a maintenance crew before. Clean the aircraft and put the thumb up when the engine is started. Spending uncountable shifts to understand what is meant in the instruction written explicitly for him or her. So the so-called maintenance manual. In some cases, if you do it like it is written there, the aircraft is unserviceable. Keep the aircraft in airworthy, good and safe condition for flight. Who is for B? Okay. We do not have much of requirements, but I just want to point out 30.1 because it says something about identification to its labeled to its identification and all this stuff. It is not only the ETSO equipment, and I say, yeah, it's a placket on it, done. If you install pipes, make sure they're adequately labeled, not only with the EPA marking so that everyone knows you have installed it and you have designed this fancy part, also for simple things like the tubing I showed here. In the design, consider also that labeling is nice, but if you have let's say two connectors for two different systems and you put it close to each other, make sure they are of a different type. Otherwise, it will happen at 3 o'clock in the morning that someone switches these connectors. And if this is a junction box, it won't work anymore. Do you know why all this electric stuff works? Because there's smoke in there. And if the smoke goes out, it doesn't work anymore. So if it is switched and the smoke comes out, dead. The maintenance instructions have to be clear and precise. Think of an airliner. Think of the operation of an airliner. They do normally all these A checks during night shifts, or when the aircraft is on a C check, it's a 24 shift for 7 days. So you will have people working 3 days in night, and in the third day, you will see very fancy stuff at 3 o'clock in the morning, I can assure you. And if the instruction he has to follow is not really precise, is not really clear, he will make some failures. Or she, sorry. So we are at the more or less last section. You remember the Swiss cheese model. My question is, on which of the defense lines are we traditionally focusing with initial certification? Short moment to think. All of them? Only one? Okay, I would say it's only related to crew actions during the operation. And we are focusing here on fail or absent defense probabilities. Is this the best we can do? Of course. Now I have some practical examples. I receive from my colleagues from operations department at Austria Control very often a not so nice feedback regarding STCs, regarding the design of the aircraft. They explained to me that aircraft modified with STCs do often not comply with ops rules. The associate manuals like the AFM are misleading, or they think they're simply wrong. Procedures are not clearly identified. At the very beginning, when they came up to me, I just said, yeah, just do your job, I do mine, everything's okay. But after years, I figured out that this silo thinking is completely wrong. You need to have the link to the ops department. Why did I mention this picture? Do you know why? What you can see here is an emergency exit. And what you can see on the picture as well is that you don't see the window on the other side of the aircraft. This is because there is something hanging there. Why is something hanging there? Because there is a pole installed where you can put it in. So do you think it's a good idea to store your clothes in front of an emergency exit? Maybe not. But this aircraft doesn't have any required cabin crew, so no one to take care about. This might result in let's say delays until the aircraft could be operated, which puts additional pressure on the operator because he bought it already, and he often needs to earn money with it, and this results in additional pressure on individuals again. And at a certain pressure level, they are willing to take shortcuts, and shortcuts we know might be a little bit detrimental to safety. If you have a look at Oro FC 115 from the ops rules, there is an A missing. The crew is regularly trained on crew resource management based on aircraft design. So they take the design into account. So it is worth thinking about these nice to have things like EFBs or other things. I have examples for this as well. One example is you install a system which is for situational awareness only. On one hand, we know that such functions might enhance safety, and we figured out that some not so trained person might find it helpful. May I ask, who of you has a private pilot license? Okay, and you're flying regularly VFR? Okay, So sit in the back when one of your friend is flying VFR and have it and take the time how often he looks out of the window and how often he looks on the instrument panel if you have an EFIS instrument panel in this small aircraft installed. And you will figure out the head's downtime is, in the meantime, 60 to 70% during a VFR flight. Is it the intention of this kind of operation? Maybe not. The next thing is what it can, or the picture you can see here below, is for situational awareness only approval. So you will have red indications for situational awareness only, and you will have a pull-up. When we were flight testing this system, we were in front of the mountain, and if you try to pull up with the performance of this aircraft, you will end up in the mountain. So this needs to be assessed. Okay, someone might say the pilot has to stick to limitations written in the handbook. Yeah, sure, of course, no violations, they're all perfect. Who of you, driving a car, performs a daily check of the tire pressure of your car? Hands up. Who? Yeah, one. Okay, even one.
It's an automated system.
For situation. Okay. Who weekly? Hands up. Good. Whenever the tires are changed? Yeah, it's the same with me. During maintenance, you assume that when you go to the garage that they check the tire pressure. Secret, they don't. It's not on their checklist. So why don't you check the tire pressure, which is essential for the safety of driving a car, not daily? Because you never had a problem with it, or you have an automated system. So the next example I want to come up is the no hazard, no credit basis. I really like this one. You know, you have all the things you have also with for situational awareness, but as these are no credit things, one of the most or the vast majority of arguments why to install it is the flight crew can disable it if he's in a high workload situation. But is it also addressed? Is it also checked how often or how long it takes to deactivate all these no hazard, no credit for situational awareness systems in the cockpit? And how should the pilot distinguish when he is in the stress situation? So there's something going wrong with his aircraft. What of the information presented to him in this stress situation is really nice to have, and which one is trustworthy? Okay. This one I really like because as a former maintenance guy, I also always was used to make jokes about pilots. So some of them were regarding sleeping. Now I learned that the OPS rules, CAT Pol MPA 210, defines controlled rest. It is beneficial for the flight crew to relax in low work situation, to be focused and awaken when the high workload comes up. As I showed you before, the graph, if the pilot is able to sleep have a power nap, sorry, sleep is not the wrong, is not the correct word. Have a power nap prior the approach, it's beneficial. My question is, how should he do it on an aircraft when there is no backrest installed? These are things, operations comes up because they have to have a procedure how a controlled rest is completed. Yeah, still works. Here I have an example of what is written in CS25 and what is written in the operating rules. So most of you will know 1423 G, for each required floor level passenger emergency exit, which has an adjacent cabin crew member seat, have a microphone which is readily accessible to the seated cabin crew member, except that one microphone may serve more than one exit, provided the proximity of exits allows unassisted verbal communications between seated cabin crew members. This is a definition we like. It gives us possibilities, and it's more or less clear. So then we have a look at what the operation rule says. In the case of airplanes where at least one cabin crew member is required, be readily accessible for use at required cabin crew member stations close to each separate or pair of floor level emergency exits. Did I explain what is required here? It's the handset. Sorry, I forgot to mention this one. Example. Your customer comes to you, wants to have his cabin refurbished and all this stuff. And one of this action is that you should do a little rearrangement at the back of the aircraft. So the rearrangement consists of the removal of a seat, because it's always damaged due to whatever, boarding, whatsoever. And you put the required cabin crew, which was situated here before, to a seat over here at the other side of the aisle. No problem at all. So you have one required cabin crew in the middle for the direct free requirement, and one sitting here. But the cradle is still here. My question is the operating rule fulfilled, yes or no? And I do not answer this one. I regularly work with AMAG Aerospace together, and I just want to point out one thing I experience as a good thing. So AMAG reviewed the existing design when they installed the STC and figured out that in the cockpit there was a slight inconsistency in switch arrangement, which had to do with human factors. And because this is not good, simply saying that, they corrected it because of the human factor considerations. Although they were not responsible for the initial design, just to improve the situation in the cockpit. And this is a really a good example on, if you see something which is wrong, please correct it. Maybe you can also charge your customer for it, but this is a different story. Another thing is, operating rules tells you if you have an aircraft below 19 passengers, you do not require a cabin crew. Correct. But it does not automatically mean that you never need a cabin crew when you have less than 19 pax. If you have a larger aircraft, let's say a single aisle aircraft, and you modify it to a business craft aircraft, where you have 19 passengers, and you put all the tasks to the flight crew, then you will need to have the assessment how the flight crew will be able to do the firefighting, all the instructions of the passengers, and so on and so forth. Also, these aircraft are regularly flying commercial air transport. The same rules apply to them as well. And when you're doing this assessment really a little bit more restrictive, you will figure out that this kind of aircraft will need a cabin crew, although you have less than 19 passengers. So this is my last one, I guess. I hope. It's regarding small aircraft. You know, all these CS-23 aircraft, they tend to have the same information displayed like on the big ones, except that the panel is much smaller, so you have less space. So if you have less space, what are you doing? You're doing downsizing. If you're downsizing, the letters and symbols get smaller and smaller and smaller because you have to bring up more of them. And when you're flying with this aircraft, you can't read anything on it because of panel vibrations and all this stuff. So is it really a good idea to install such a system? Wouldn't it be better to convince your customer that he should invest in something he can take really a benefit out of it? So my conclusion on human factors is that human factors is vital to safety. And what I've seen, sorry. What I've seen in the past is that when the design wasn't really that good, it was tried to make better with predefined procedures. I'm asking again, if I have a procedure which is not obvious, which is not intuitive, isn't it most likely that the pilot will unintentionally violate this procedure? There's one saying is, don't elaborate on complex solution for simple problems. Just change it. It's in some cases, it's much better to have a slight design adaptation than trying to find a really complex solution. Use new AMCs, because in the later AMCs you will find more about human factors than 50 years before. And follow the KISS principle. There are several possibilities how you say KISS. It's keep it short and simple. I like it, keep it simple, stupid. Review all the requirements of your customer. Have a look at the ops rules. Have a look at Part 145 rules as applicable. Try to make sure that your customer will be able to operate the aircraft in his environment. I hope you liked this short presentation, and also I was afraid that I won't make it in time. I did.
Thank you very much for that.
So I hope that you don't have any questions.
There are a couple of questions, but as usual, I think we will keep them and answer them later on. Most probably, as you can see, if you are currently logged in, most of them should be answered by cabin safety experts.